Good morning, students. Okay. Good morning, students. Today at 9:45 you have
Good morning, sir.
mock quiz exam. Okay. Now, in last
So
class,
what will be the, pattern for quiz? How many questions?
multiple choice questions, 5 questions, 5 minutes.
Okay, sir.
Okay. Right. In the last class, we discussed about binary codes. In binary codes, we discussed about BCD code, XS3 code, 8, 4, -2, -1, 4, 2, 4, 2, 1, 4. Okay. Now, for example, if you want to represent a number 5, how you represent this number 5 in each binary code? In BCD code, another number BCD code is 84214, and how you write 5? 5, these are the weights, 8, 4, 2, 1, these are the weights. So make the equal of the weights to this digit. So if you add 4 plus 1, you will get 5. So wherever the weights are there, keep 1, remaining 0. This is 5. XS3. XS3 nothing but binary equivalent of the digit by adding 3. By adding 3, whatever may be the digit, for that you have to write the binary equivalent. 5 plus 3 nothing but 8. How you write the 8? 1, 0, 0, 0. I asked you to remember 0 to 15 decimal digits binary representation. That is nothing but base 2 table. You have to represent. You have to remember. This is the 8. Here you have the 4 weights, and by adding which weights it is equal to 5. By adding which weights you can add 8 minus 2 minus 1. So 1, 0, 1, 1. And which weights, by adding which weights you can make it equal to 5. So I asked you to remember this first letter is H. So decimal digits we have 0 to 9. So for 0 to 4 it is 0. For 5 to 9 it is 1. So 5 is nothing but 4 plus 1. 5 is nothing but 4 plus 1. So you can use for 5 to 1 it is 1. So you have to write as this is 1, 0, 1, 1. Okay. So for second half of the decimal digits, this should be 1. So it is one weight is 1. So 2 is there. So by adding which weights it is equal to 5? By adding 2 and 1. Okay. You can't go with the 4 plus 1, because for the remaining half of the digits, this first bit should be 1. In this way, we discussed about the binary codes. Now we go with another binary code, and we know that 8, 4, -2, -2, -1. These are known as self-complementary codes. self-complementary code nothing but by inverting the binary code, if you get the nines complement, that is known as self-complementary code. That is known as self-complementary code. And BCD code 84 minus 2, 24, 21 are weighted codes because those positions having some weight. This XS3 and the code which we are going to discuss, these are the non-weighted codes. These are the non-weighted codes. Okay. Now, next one is gray code. Gray code is also a binary code. It's also a binary code. Now, here we need to know how to represent the decimal digits in gray code. How to represent the decimal digits in gray code. So constructing the gray code, here the decimal digits you write. Here gray code. First 0, 1. 0 and 1 represented similarly in gray code. Also same. It is 0, it is 1. Then 2, 3. So to represent the 2, 3, just to place one mirror. Place mirror. Okay. When you place the mirror, what will happen? This first letter will be appears nearer. 0 will appear farther. 1, 0. Now fill upper bits with 0, lower bits with 1. Because for 4 digits, you need to represent 2 binary bits. You need 2 binary bits for each letter. So fill upper bits with 0, lower bits with 1. Next, 4, 5, 6, 7. Now place a mirror. Place a mirror. So when you place the mirror, what will happen? This 1, 0 will be appear here. 1, 1 will be appear here. 0, 1 will be appear here. 0, 0 will be appear here. When you place the mirror, now fill upper bits with 0. Upper bits with 0, lower bits with 1. Like this, you can construct gray code for the decimal digits you want, 10, 11, 12, so on. So again, you have to place the mirror at 7. And so you'll get 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, so on. So fill the upper bits with 0, upper bits with 0, lower bits with 1. Lower bits with 1. So this is the format of constructing the gray code. And where to place the mirror? Mirror, you have to place at places of power of power of 2. Okay, you have to integer power of, you have to place the mirror at integer power of 2. That is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, so on. So this is 2 to the power of 1. You place it in mirror after 2 digits. Then 2 to the power of 2 means 4. You place one mirror. Then 2 to the power of 3. After 8 digits, you have to place one mirror. After 16 digits, you have to place one mirror. Like this way, you have to construct the gray code. Okay. And the assignment question is the third assignment, I think. Okay. Third question in the assignment. Construct a gray code. Construct a gray code for 0 to 31 decimal digits. 0 to 31 decimal digits. Construct a gray code for 0 to 31 decimal digits. Okay, everyone note out this question. And
Sir, is this the third assignment question?
third assignment.
Sir, the first one was for decimal to base 16. This is the second one, I guess.
Okay, let it be, Amma. If I remember, I will post once again. Okay, this is the question. Construct the gray code for 0 to 31 decimal digits. Okay, so once again, I will explain how to construct. For the decimal digit 0 and 1, the gray code is normal only, 0, 1 only. Then you have to place the mirror at the 2 to the power of 1 after 2 digits. After 2 digits, you place one mirror. When you place the mirror, the numbers represented like this. Okay. Then fill the upper bits with 0. Above the mirror, you have to place the 0. Below the mirror, you have to place the 1. Then after 4 digits, you have to place one more mirror. Then the gray code will be appear like this. Then fill upper bits with 0. Lower bits with 1. For remaining 8, 9, 10, 11, 12, 13, 14, 15. So for the 8 bits, after 8 bits, place one mirror. Okay. After 8 decimal digits, place one mirror. Then you will get 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0. So fill upper bits with 0, lower bits with 1. So fill 0. So for the 0 to 31, now place the mirror after 15. You people place the mirror after the 15, then write down. Then write down. Now the important point you need to remember is take any two serial numbers. Take any two serial numbers in gray code. Any two serial numbers in gray code. Take any two serial numbers like this. Okay. The distance between these two numbers, distance means the difference in the bits. Okay, 0, 0 is same, 1, 1 is same, 0, 0 is same, 1, 1 is same, 1, 1 is same. So only one bit is different. The difference in the one bit is known as distance. Generally, it is known as distance between the two numbers. So gray code is having one bit distance between two serial numbers. One bit distance between two serial numbers. If I give you two numbers like this, what is the distance between these two numbers? I ask you, find out the distance between these two numbers. So you are need to identify how many bits are different. How many bits are different? What is the distance here? Anyone? For these two bits, what is the distance? Ma distance enta? Same bits cancel. This is 1 to 0. So this is 1 bit. It is also changing. It is also changing. So we have 3 bits different. 3 bits different. So the distance between these two binary codes is 3. The distance between these two binary codes is 3. You understand? Okay. So in gray code, the distance between any two serial numbers is 1 bit. The distance between any two serial numbers is 1 bit. Next, ASCII code. ASCII code. This is a alphanumeric code. This is a alphanumeric code. Alphanumeric means along with numbers, it have the code for alphabets as well as some special characters. So using ASCII code, we can have binary code for alphabets, small and big, special characters, and numbers. Okay, you can see these 3 different types in keyboard. In keyboard, we have alphabets, special characters, and numbers. Alphabets, special characters, and numbers. So you can have a different binary code for each alphabet or special character or number. Okay. ASCII, nothing but American Standard Code for Information Interchange. The full form is American Standard Code for Information Interchange. Information Interchange. American Standard Code for Information Interchange. So here in ASCII code, each bit, each alphabet or special character or number represented with 7-bit code. Say 7-bit code. So for each letter, whether you take capital A, you have to represent with 7 bits. Okay. Okay, this is not exactly. I'm just giving you one example. Okay, if you want to represent B, it is also 7. It will be represented with 7 bits. Like this. If you want to represent number 2, it will be represented with like this. For example, if you want to represent a special character star, it will be represented with some other 7-bit code. Okay. Now, another assignment question is, okay, before going to assignment question, ASCII code is a 7-bit code and it is an alphanumeric code. Alphanumeric code means we can represent a binary code for alphabets, special characters, and numbers. It is okay. These are the symbols we have on the keyboard generally. So generally we transfer the information from the keyboard to the computer through ASCII code generally. Okay. Now write your name in ASCII code. Write your name in ASCII code with even parity and mention memory to store and mention memory to store it. Okay. Generally, how much memory needed to store your name? How much memory needed to store your name? Okay. I will explain with my name. Then you go on with similar way. Okay. This is the next assignment question. Write your name in ASCII code with even parity. Okay. So my name is Rajesh Atluri. Okay. So how many symbols are there? R, A, J, E, S, H, space. Space is also one symbol. Space is also one symbol. Okay. Now R. R will be represented with 7 bits. R will be represented with 7 bits. And I am asking you to represent the symbols with parity bit. So along with the 7 bits, which are ASCII, 1 bit I am allocating for the parity bit. For parity. So look in the Google, what is the R letter will be represented in ASCII code. For example, it will be represented with 001011. So write this 7 bits here. So parity bit you have to find out on your own. I will explain after this how to write the parity bit. So write down the 7 bits by looking into the Google. Similarly, represent the A with the 7 bits by looking into the Google in ASCII code and leave one for the parity bit. Leave 1 bit for the parity. Like this J A. So how many bits are there totally? How many letters are there? 1, 2, 3, 4, 5, 6, 7. This is also count 8, 9, 10, 11, 12, 13. So this is to represent each symbol. We need 8 bits. Okay, I have 13 bits. I have 13 symbols. My name is having 13 symbols. Okay, I already told you 4 bits known as nibble, 8 bits known as byte, 16 bits known as word, 32 bits known as double word. Okay, already I explained this one. So here each symbol is taking 1 byte. It is taking 1 byte. So 13 symbols take 13 bits. So to store my name, the computer needs 13 bytes storage. It needs 13 bytes storage. So in computer, the memory is divided into the bytes. Okay, each location having 1 byte. So it has to allocate you 13 bytes, 13 storage locations. Okay, the total storage needed is 13 bytes. Okay, now like this, write your own name and mention your storage needed and write down your name in ASCII code along with the parity bit. ASCII code. Okay, now next, one small topic I'm to discuss before going to further. BCD addition. Okay, how to add the numbers with BCD code. How to add the numbers with BCD code. So, for example, I want to add two numbers, 8 plus 8. I want to add these two numbers. Okay, there is one calculator is there. In calculator, 1, 2, 3, 4, 5, 6, 7, 8. I want to add 8 and 8. Okay, so you will give the information 8 and 8 and consider the information is passing through BCD code. So 8 will be represented in BCD code 100. This is also 100. Now add 0, 0, 0. 1 plus 1 nothing but 1 0. So 1 0. So in BCD code, 4 bits represent as 1 bit. So this is nothing but 0. This is nothing but 1. So when you add 8 plus 8, you will get the result 10. But it is not correct. But it is not correct. You have to get the result 16. You have to get the result 16. In similar way, when you add two numbers with BCD code, 8 will be represented as 100, 10 will be represented as 011. Okay, when you add this one, you will get 111. But this is not a valid number in BCD code. Not a valid number in BCD code. So when you do the addition of the decimal digits using BCD code, okay, you will get these type of results. 8 plus 8, if you do, you are getting 10 result. 8 plus 7, that is not a valid BCD code number. So how to do addition of the BCD numbers of the decimal digits using BCD? You will see. First one, represent given numbers in BCD code. Represent given numbers in BCD code. Second, if addition produce a carry, or value greater than 9, value greater than 9, add 6. Okay, carry are not a valid number. When we get the not valid number, when the number is greater than 9, add 6, add 6 to the result. Third, again check if addition produce a carry or not valid number, add 6 to the result. Okay. Again check result. Again check result. And repeat step 2. Repeat step 2 until we get valid numbers. Valid numbers. Okay. I'll explain with one example. Okay. See, 6 is nothing but 0, 1, 1, 0. So when you add 8 plus 7, you have to get 15. But you are getting this one. This is not a valid number. So when you get not a valid number, you have to add 6. So it is not a valid number. Valid number. In BCD code, only 0 to 9 are valid numbers. Remaining are not valid numbers. So add 6. So adding 6 nothing but add 0, 1, 1, 0. So add 6. When you add 6, 0 plus 1, 1, 1 plus 1, 1, 0, 1 plus 1 plus 1, 1, 1, 1 plus 1, 1, 0. Now 4 bits represent as one digit. So this is 5 and this is 1. 1 is there. So remaining considered as 0. So you will get 1, 5. So if you get the result which is greater than 9, which is greater than 9, then add 6. Then add 6. Then one more problem is 8 plus 8. 8 is nothing but 1000 and 1000. When see after adding 6, we are getting the carry. If the addition produces a carry, this is before adding the 6 sum. This is before adding 6. This is before adding 6. Okay. If the addition produces a carry before adding 6, you have to add 6 to the result. So here 0, 0, 0, 1 plus 1 means 1, 0. So when you are adding 4 bits, you are getting 1 bit extra. So this is carry. If there is a carry, add 6 to the result. So add 6, 0, 1, 1, 0. This is add 6. So 0, 0, 1, 1, 0, 1, 1, 0, 1. So this is nothing but 6. This is 1, 1, 6. Okay. So if the addition produces a carry or not a valid number, add 6 to the result. And again check the result and repeat step 2 until we get the valid numbers. So we'll go with one more example. I want to add 98 plus 37. First represent 98, step 1. Represent 98, 37, both are in BCD code. So 98 BCD code is represent 9 separately, 8 separately. 9 is 1001, 8 is 100. 37 0011 011. Now add 1 1 1 1 1 1 0 1 0 1 1. You are getting 110041. See, in BCD code, only 002 1001 are valid numbers. And these are not valid numbers. Not valid numbers. So this is not a valid number. This is not a valid number. Both are not valid numbers. If there are valid number, if both are not valid numbers, then add 6 to each not valid number. Add 6 to each. Add 6. So add 6 here, 0 1 1 0. Add 6 here, 0 1 1 0, because both are not valid numbers. 1 1 0 1 1 1 0 1 1 1 1 1 0 1 1 1 2. Okay. Now look at the 4 bits as a group. 0 1 0 1 valid number. It is valid number. This is valid. After adding 6, if it is produce carry, we do not add them. Okay, we do not add. So the value is 1. This is 0 1 with 3. This is 5. 1 3 5. So by adding these two, you will get 1 3 5. This is the BCD addition. Okay. Next, we will go with one more example. All of you try to do this problem. 2592. Okay, Amma, go with the steps, Amma. Go with the step. Step 1 is represent code in BCD code. Next, add. Next, check valid number or not. If there is not, if not a valid number, you got add 6. Okay, why we are adding 6? Add 6 because there is a visual difference between binary number and BCD code. BCD code is 6. BCD code is 6. So if you write the binary table nothing but base 2 table and BCD code. Okay, Amma. Now I am writing 0 0 0 0 1 0 0 1 2 3 4 5 9 1 0 0 1 up to here same. I will write here 1 0 1 0. Here 0 0 0. Plus 10. No? So we will represent with 4 bits. We will be represent with either like this. Next 1 1 1 0 1 1 1 2 100 1100 like this. 15 I will write 111 100 10. 16 1000 I will write here 10110. Now see 10 in BCD code represented as 1 4 zeros, 16 in binary represented as 1 4 zeros. So there is a visual difference between binary and BCD code is 6. So we add 6 to the binary numbers to visualize in BCD code. To visualize in BCD code. Okay, ma'am. To erase the binary visual difference between binary and BCD code, we add the 6. Okay, ma, everyone log on to the Moodle and write the exam. Okay, everyone log on to the Moodle and write the exam. Quiz is open amma 9:45 to 9:50. So everyone open the Moodle and write on the exam.
Sir, can you give a bit more time, like 5 minutes extra, because it's exact 9:45.
Okay, time. Okay. I will look at it. Easy questions, amma. No need to give extra time. You can see once. Very easy questions. First quiz na, I have given very easy questions. I have given 2 minutes extra. 9:52, the exam will be closed. I've given 2 more minutes extra. No problem. Everyone answer the quiz question.
Sir, it's still showing 40 seconds for me.
40 seconds, Amma.
సార్ ఇంకా 40 సెకండ్స్ అనే చూపిస్తున్నాను నాకు.
నేను ఇప్పుడే చేంజ్ చేశాను, మరి రిఫ్లెక్ట్ అయిందో కాలేదో మరి.
seconds అని 13 seconds.
ఓకే అమ్మా, నేను ఒకసారి మళ్ళీ ఎనేబుల్ చేస్తాను అండి. ఒకవేళ 5 minutes ఎక్స్టెండ్ చేస్తాను. ఒకవేళ మీకు క్లోజ్ అయితే చెప్పండి, నేను మళ్ళీ ఎనేబుల్ చేస్తాను.
అయిపోయింది సార్.
క్లోజ్ అయిపోయిందా?
లేదు, టైం లెఫ్ట్ 1:59 ఇప్పుడు వచ్చింది, అంటే ఫినిష్ అయ్యేటప్పటికి.
ఓకేనమ్మా, రైట్.
సార్ క్లోజ్ అయిపోయింది సార్.
కొంతమంది క్లోజ్ అయింది అంటున్నారు, కొంతమంది కాలేదు అంటున్నారు.
క్లోజ్ అయిపోయింది సార్. క్లోజ్ అయిపోయింది సార్.
క్లోజ్ అయిపోయిందా?
క్లోజ్ అయిపోయింది సార్ మాకు కూడా అందరికి.
సార్ మాకు అంటే నాకు కాలేదు, 128 అని ఉంది ఇంకా నాకు.
దానికి ఒక్కతను కాలేదు సార్, మాకు అందరికి అయితే అయిపోయింది. 3 minutes 40
అయితే నేను ఒకసారి మళ్ళీ ఎడిట్ చేస్తానమ్మా. ఫస్ట్ క్విజ్ కదా, ఓకే. మీకు ఎడిట్ క్విజ్. ఒక్క నిమిషం, మళ్ళీ ఓపెన్ చేస్తే ఓపెన్ అవుతుందా అమ్మా మీకు? హలో,
లేదు సార్,
కావట్లేదమ్మా. సరేనమ్మా, అయితే నేను సేమ్ క్విజ్ను 9:53 to 10 వరకు ఎనేబుల్ చేస్తానమ్మా. మీరు కంప్లీట్ చేసేసేయండి. మీకు లింక్ జనరేట్ అవుతుంది అనుకోండి.
ఓకే సార్.
7 minutes. ఓకే అమ్మా, 9:53 అని పెట్టాను. ఒకసారి 9:53కి ఓపెన్ చేయడము, ఒకసారి చూద్దాం. అమ్మ, నువ్వు ఇంతకుముందు రాస్తున్నావు కదా, క్లోజ్ చేయమ్మా. నువ్వు ఒకసారి క్లోజ్ చేసి మళ్ళీ ఓపెన్ చేసి. 9:53 అని పెట్టాను, బట్ నెక్స్ట్ టైం ఇట్ విల్ నాట్ హ్యాపెన్స్. నెక్స్ట్ పేజ్ కొంచెం ప్రాబ్లమ్స్ మంచిగానే ఉంటాయమ్మా. ఐ విల్ గివ్ సమ్ ఎక్స్ట్రా టైమ్ ఆల్సో.
Sir, it is showing I already attempted.
ఆల్రెడీ అటెంప్టెడ్ అంటే ఓపెన్ కావట్లేదా?
కావట్లేదు సార్, అది ఎక్స్టెండ్ అయిందని చూపించట్లేదు.
ఎక్స్టెన్షన్ చూపెట్టలేదా?
పాతదే చూపిస్తుంది.
చూపెడుతున్నా, ఒక నిమిషం.
మీరు పాత టెస్ట్ మార్చారు సార్, కొత్త టెస్ట్ మార్చారు.
ఓకేలేమ్మా, లైట్ తీసుకోండి దీన్ని. నెక్స్ట్ మీటింగ్ నేను ఒక 2 minutes ముందే మిమ్మల్ని అలర్ట్ చేస్తాను. ఓకే
సార్, ఈ ఫస్ట్ క్విజ్ వాయిడ్ అయిపోయినట్టే కదా సార్? అంటే నేను అటెంప్ట్ చేశాను కానీ 2 minutes ఉండవు సార్ టైం నాకు.
కన్సిడర్ చేయండి అమ్మా, నేను నెక్స్ట్ మీట్ నుంచి కన్సిడర్ చేస్తాను. నెక్స్ట్ నుంచి కన్సిడర్ చేస్తాను.
సార్ ఇంకోటి రేపు క్విజ్ 2 అని కూడా రాస్తుంది, అది దేంది?
సార్, ఇట్ ఈస్ నాట్ ఓపెనింగ్.
ఏంటమ్మా?
సార్, ఇట్ ఈస్ నాట్ ఓపెనింగ్.
అదేనమ్మా, ఓపెన్ కాబట్టి కన్సిడర్ చేయను. ఓకే అమ్మా, ఇప్పుడు కొంచెం టైం ప్రాబ్లం వచ్చింది కదా, నెక్స్ట్ టైము నేను దాన్ని పర్ఫెక్ట్గా ప్లాన్ చేస్తాను. మీరు అందరూ కొంచెం ముందుగానే ఓపెన్ చేయండి, ఒక 2-3 మినిట్స్ ముందు ఉండగానే ఓపెన్ చేయండి. ఓకే, ఇది ఐ విల్ నాట్ కన్సిడర్ దిస్ వన్, డోంట్ వరీ. రైట్.